Hello. For this movie, we are going to take an equilateral triangle and inscribe it in a circle. So what we're going to do is we're going to start off with 2 points, A and B, and we are going to create a circle around A that has a radius of AB. So we're going to do circle with the center, A to B. So what I'm going to do over here is I'm going to go back to move, and I'm going to click on this circle because this is going to be our main circle. So let's get this to be a little thicker, and I think we're going to add a color to it. Let's make it red so that we can see that this is definitely our main circle. What we're going to do here is we are now going to create a circle that goes from A to B, but it goes around B. So I'm going to click from A to B, but place it down at B. So let's do that. So now we've got 2 circles and we've created 2 intersection points. Let's put some points on there where they intersect, C and D. And then let's talk about this. If we're looking at our main circle, the red one, we are going to create an equilateral triangle. And an equilateral triangle is 3 sides, and all 3 sides are congruent. So what I've got here is if we were to connect A to B, that would be a radius. And CD is our perpendicular bisector. And what we know is if we've got a chord CD, I'm going to go ahead and draw that chord C to D. And then I'm going to go back over here to move. And this is going to be part of my equilateral triangle. So I'm going to make it a little thicker. I'm going to put some color to it. I'm going to make it blue. That CD is a perpendicular bisector to AB. It's a chord CD, and if you create the perpendicular bisector, you know you have a diameter. So, interestingly enough, if you connect A to B, yes, you can take it all the way across and get a diameter. Can't talk today. So the next thing that we're going to do is we're going to put our compass from C to D, and we're going to put that circle down at D, or I'm sorry, at C. And then we're going to connect D to C and put that circle down at D. Now what that does, I know other than create a lot of confusing diagram, is it creates another point over here, point E. And you can see that point E is in fact on that diameter AB. And if we look at E, we can connect E to C and connect E to D with a segment, E to C, E to D. And then I'm going to go back over here to move, and that EC, I'm going to make a little thicker. I'm going to put a color blue to it. And I'm going to connect E to D, make it a little thicker, and put a blue color to it. And you can see the equilateral triangle, ECD, inscribed in circle, the red circle. And we call that circle A because A is the center. Now let's verify that. If we go down here under measure, you see distance or length. Let's verify, in fact, that it is an equilateral triangle. And what I did was I just clicked on each of those lengths, and I see that they're all 8.4. Brilliant. We have constructed an equilateral triangle in this circle. And you notice if you move B in and out, it stays equilateral. If we move point A, it just moves our circle, so that is not helpful. But you can move points and see that you still have your equilateral triangle.